Example 14. 20 grams of ice at 0 degrees Celsius is dropped into 60 grams of water at 50 degrees Celsius. Calculate the final temperature. Okay, given the specific latent heat of fusion and specific capacity of water. Okay, so what happened is that this is ice is at a colder temperature than the warm water. Then we know that when you have a mixture of a warm temperature and a cold temperature, the warm water will lose heat to the colder ice. So the warm water, after it loses heat, temperature will drop. But for the ice, when it gains the heat, its temperature will not rise immediately because it's now at its melting point. When ice receives heat at the melting point, its temperature will not change, but instead the ice will melt. And after the ice, and even when the ice is melted, the temperature remains 0 degrees Celsius. It's still cooler than the warm water. So as the ice melts, it still continues to receive heat from the warm water. And so the ice will continue to melt until all of the ice will fully melted. But even after the ice is fully melted, the temperature of the melted ice, the melted water, its temperature will still be 0 degrees Celsius. It's still cooler than the warm water. So even after the ice has fully melted, its temperature is still 0 degrees Celsius and it still continues to receive heat from the warm water. And so the melted water, the temperature will then start to rise. So when the warm water temperature keeps on dropping, then the melted water temperature will keep on rising until eventually they will reach a final temperature. So basically in this question, in this problem, one party will gain the heat. In the end, it will reach one final temperature, and the other party will lose the heat. The party that gained the heat is the ice, and the party that loses the heat is the warm water. But the heat gained by the ice comes in two stages. Initially, the temperature of ice doesn't change, doesn't rise. Instead, the ice will melt. Okay, so this is the latent heat. The formula is mass times the L. Okay, 20 grams is 0.020 kg, and this is the specific latent heat of fusion. Then, after the ice has fully melted, it becomes water at 0 degrees Celsius. Then it continues to receive heat, and here the temperature rises, and we use the formula mc delta theta. Okay, this is the mass of the melted ice, which is 20 grams, 0.020 kg. This is the C, the small c, the specific capacity of the melted water, 4200 joules per kg per Kelvin, and times the change in temperature. If the final temperature is theta F, the change in temperature will be theta F minus 0. Okay, this is the heat loss by the warm water, the initial water initially at 50 degrees Celsius. Okay, this time is heat loss by water. We still use the formula mc delta theta. This is the mass of the warm water, 60 grams. So it's 0.060 kg. This is the specific heat capacity of water. But this one, change in temperature, because we are dealing with heat loss. If it's heat loss, that means the initial temperature is higher, the final temperature is lower. So for heat loss, in finding the change in temperature, we must use the final temperature. Okay, no, not the final temperature. Use the initial temperature minus the final temperature, because the final temperature is smaller. You must get the positive number here. Then it can be equated on the left hand side, which is also a positive number. Okay, so this is the left hand side is all the heat gained by the ice in two stages, and on the right hand side is the heat loss by the warm water. Okay, so we work it out and we get the answer, final temperature 17 degrees Celsius.